Alright, I'm back, and I'm going to start with 200 ANKI flashcards, and I'm going to get into writing a paper. So welcome to the Last Resort Network. I'm Zach, obviously, and I got my new cameras set up. So I got this camera, then I also have share screen on here, so I can show kind of where my studying will be, so you can kind of see that. And I'll reorient these to make them look better eventually, but for now this is the setup that I have, and we will see how it goes. So for those of you who aren't in medical school or don't know much about these types of studies, this is called an 8-bit do, and it's really useful in medical school for doing ANKI. So what I do is, I got the cheapest one. It's $12 on Amazon. You just turn it on, and then you have to pair it and code it. So I already coded it. It takes a while, but once you pair it and code it to your computer, then you are able to use it for ANKI. So each of these buttons has different purposes, and I have coded it, and I put a key here so I know which button I coded which function. And I put it on a sticky note on my desk, the wall of my desk. I'll have to do an office run through at some point. So when I go over here to this, I can, from here, click it. So like regulating gene expression, transcriptional regulation by proteins. So that would be, I don't know, different promoters, or I don't know. Let's just see. So I open it, it works, okay. Because sometimes it doesn't work. So chromatin condensation transcription factors. So the second one is closely related to what I said. The first one I forgot. So they can condense and decondense the chromatin, which is the bundled up DNA, and histones regulate that. So I'll do that hard, so I have to remind myself. So B is hard, okay. Even though it's not necessarily hard, this is basics. So that's what we'll start off with the first 2 hours today. I'm going to start that off. So I'll be talking through this, and then I'll do about an hour or maybe 2 hours of paper writing. I have a big paper to write, maybe 4 or 5 pages. And then I'll finish this off with a little bit of Eusebius. I said I was going to do some Eusebius last night, but I ended up not doing it. This is the, basically the church history. It's kind of almost the official church history book of the Christian Protestant Church, obviously Catholic Church coming from that, and many other denominations splitting off. So what I've got today is coffee. My mug today is one of my favorites, probably my favorite, this little puppy mug. It's very cute. I made Ethiopian pour over this morning, and I also made a one on the Aiden Fellow. So the Fellow Aiden, sorry, it's the new coffee maker by the Fellow brand. It's very nice. So I got this coffee cover to keep the heat in, and I also got this carafe, which is very nice. I store all the coffee in here. So yes, I will be drinking all this coffee. Yes, it's probably like 300 milligrams of coffee, but that's where I am in life. So the carafe keeps it nice and warm, and I got these crackers to dip in the coffee throughout the stream. We'll see how that goes. So I'm going to reset the timer. I'm going to get started with ANKI. My goal today is to get 200 flashcards done of ANKI. And not just 200 flashcards of review, but 200 new flashcards. So I'm hoping I can get that done in the first 50 minutes. I've done it before, and these are easier questions. This is from the Foundations 1. As I prepare for Step 1, it's the United States Medical Licensure Exam. It's one of the hardest exams. Step 1 covers all the different blocks that I do in medical school. So I am prepping for Step 1. So this is going to be Foundations 1 review. So this is the very beginning of med school. So this content will be pretty introductory. It's going to be gene expression, biochemistry, genetics, stuff like that. So, yeah, I'm ready to dig right in. Let me start this timer. Okay, and we are off. Let me get this first sip. Oh wait, hold on. I forgot that it has to be 50 minutes, so let me go back over here. One second, almost there. 6,000 seconds, or 3,000 seconds. I gotta save it. Okay. All right, here we go. So first study session, go. Okay, so I'm going to share my screen of this. Go over here. How is imprinted DNA maintained? Well, when DNA replicates, one side is methylated, the other one's not, so then they methylate the other side. That's pretty simple. Methylated parental DNA is replicated. One strand is methylated, the other daughter DNA forming methylated replicate DNA. Non-methylated strands methylated fully formed. Yes, got it right. So for this one, I'm going to put 3, which is good. Okay. Regulating gene expression, chemical modifications of DNA. I'm going to say methylation. Yep. Methylation basically shuts down the DNA. It's kind of like a blocker. And DNA methylases do it. Eukaryotic polymerases blank transcribe by themselves. They cannot. They need an initiation complex. Yep. Transcriptional apparatus. Good. Histones impair blank of a gene by competing with sequence-specific transcription factors. I guess transcription of a gene, yeah. Regulating gene expression, so, and by the way, this down here, these are the numbers, so it's 2255, so my goal will be to make that 2055, to get 200 of these blue cards done. Those are new cards. I have been through this whole deck, but I'm resetting the entire thing so that I can redo it as I prep for step 1. The hard part about Foundations 1 and 2 is there's not really a great organization of all the material, because it's kind of just like throwing up on the wall and grabbing a bunch of different material. That's why you hit the ground running in med school. So I think it's good to kind of just review the material in the order that you learned it, so you can kind of create your own framework for the material. So yeah. So let me see if I can shift this so it looks a little bit better, so you can see my pretty face. Let me see real quick. Alright. Okay, let's just do it up here. And then what I'll do is sorry guys, this is my first time doing this. Okay. Alright, this should be good now. Let me see if it shows up on here. Okay. Regulating gene expression, post-transcriptional regulation types. So you got your poly A addition, your 5' cap addition, your RNA splicing, your RNA editing. Yeah, I guess transport is in there. Yeah, transport, RNA editing, polyadenylation, splicing. I didn't say stability, but okay. So I'll redo that one. So that's going to be a 2. Blank is responsible for modifying, storing, and packaging proteins and lipids. So that would be the packaging, so modifying and storing. That would be the ER. Golgi. Oh man, this has been a while. Alright. And blank imprinting, the father's allele is methylated. So this is paternal imprinting, so only maternal alleles are shown or expressed. After importing the nuclear protein, the nuclear import receptor is recycled back into the cytoplasm, which is also called the cytosol. Blank of mRNA begins at the initiation codon. Yeah, transcription, right? Okay, the translation. I mean, that's what I meant to say, so I'm saying that right. Med school is multiple choice, so luckily you can Always have a good guess. Blank results in a male karyotype presenting female sex characteristics, but without ovaries due to mutation in the nuclear localization sequence of the SRY protein. This is going to be Swire syndrome. X inactivation is an example of blank in which one of the X chromosomes of females is completely inactivated. So X inactivation, methylation. Same thing. So X inactivation is methylation. So it's when the DNA is methylated and it completely inactivates the X chromosomes of the female. So I'm going to give that a 2-day. Blank contains metabolic pathways, sites of protein synthesis in the cytoskeleton. That's going to be your cytosol or cytoplasm. Are mistakes in transcription that result in an amino acid change likely to cause deleterious effects? No, because mRNA is plenty, it's bountiful, and there are lots and lots of copies of them, so it's likely not to cause much problems in the translation field. Notice because there are many copies of mRNA molecules, mistakes at a few molecules are most likely not detrimental. Good. mRNA processing, so you got the 5' cap addition, the poly A tail addition, and RNA splicing. Yep. You notice that a gene is undergoing a lot of amplification. Does this indicate that the gene is an oncogene? No, because it could be a tumor suppressor gene or some other type of gene that's maybe even an inactive gene. You see the function of the protein, correct. P53, which is a tumor suppressor gene, undergoes heavy. Okay, same reasoning that I was thinking. So prokaryotes do not have histones, eukaryotes do. And like I said, the histones are the things that compact the chromatin. An mRNA molecule can be translated simultaneously by multiple ribosomes. These ribosomes are called polysomes. As you can see, they got all the ribosomes here. Okay. Okay. Blank are responsible for sorting of endocytosis material. This is going to be endosomes. That's kind of like the carrier protein or carrier vesicles. Proteins are synthesized in the 5' to 3' direction. mRNAs are translated. No, proteins are synthesized in the N to C direction, and mRNAs are translated in the 5' to 3' direction. Yes. Blank transcription factors bind to cis-acting elements and communicate with the initiation complex directly or indirectly. So this is going to be your general transcription factors. Your sequence-specific. Never mind. Now I could argue that that goes for both, but oh well. Okay. Prokaryotes and eukaryotes. So I put that one as hard. So that's in the 4 down here that I need to review again here. Prokaryotes and eukaryotes, difference, transcription and translation. Prokaryotes couple them, eukaryotes uncouple them. Blank are translated completely into the ER lumen, the endoplasmic reticulum lumen, and are destined for secretion out of the cell or in the lumen of an organelle. So out of the cell or in the lumen is going to be soluble proteins. Good. Blank is a series of positively charged amino acids that localize a protein to the nucleus. Nuclear localization sequence. Signal. I will count it, but I'll give it 2 days instead of 7. 5' UTR is the region of the mRNA before the initiation or start codon. Yep. Blank of mRNA ends at the termination codon. Translation. A blank is a stretch of DNA that constitutes a signal for specific proteins to bind. Oh, I mean, it's just a cis-acting element? Yeah. Some of these are just basic. Blank contains genome, site of DNA, and RNA synthesis. Yeah, nucleus, okay. To increase gene expression, genes can be blank so that a large amount of corresponding protein can be amplified. So this is a pretty cool thing. It shows the amount of copies of a certain portion of the DNA. So this is the genome, chromosome 1 specifically, and it shows how many copies are in here. So if they gain, it's going to be on this side. If they lose, it's going to be on this side. I was a genetics major, so I very much memorized a lot of these things. So at first, when you look at something like this, you're like, this looks so boring. But I think over time, when you realize like the implications of genetics in society and like what you can actually do in a lab in undergrad, you know, like literally changing the DNA of microorganisms and causing them to have different phenotypes is pretty exciting. If you put in the work and if you put in the time. That was the most nerdy thing I've said so far. The blank of a signal sequence are more important than the exact amino acid sequence. So I would say, yeah, the overall charge or structure, physical properties, correct. Destination's not bad. Yep. Protein import into mitochondria. So the protein binds to the mitochondria import receptor. Signal sequence. So it's an N-terminal signal sequence binds to the mitochondrial import receptor. Okay, so it's N-terminal. So I'm thinking it's probably going to be difficult to memorize this part. Okay, I'm going to give this one a hard and redo it. Let's see. Regulating gene expression, transcriptional regulation by proteins. Obviously, there's DNA chromosome condensation. And then there's also going to be transcription factors. In blank imprinting, the mother's allele is methylated to maternal imprinting, so the mother's alleles will not be expressed, the paternal alleles will be. Good. Systolic. So this is actually spelled wrong. Some medical schools spell things wrong. It's cytosolic fibrils converge at the nuclear side of the nuclear pore of the. I mean, it's going to be. I mean, the cytosolic basket is where my mind goes, but I'm not really sure what's asking. Nuclear basket. Okay, that's another name for it, so I got it right. Blank bind to ER signal sequence on proteins in the cytosol. They then bind to blank on the rough endoplasmic reticulum surface, which then feed the protein through a protein translocator into the ER lumen. For those of you that have just joined, I got obviously more cameras. I got my Ethiopian pour over this morning with my favorite mug. It's a puppy mug. I also got about 300 more milligrams of caffeine that I'm going to have here soon. So that's a whole carafe of pour over. So I made a few. And then I got this new thing. It's called an 8-bit do. What we do with this is it can be used kind of as a joystick or almost like a switch controller to be used for ANKI. So this right here that you're seeing on the top left of the screen is ANKI, and then I am doing some Foundations 1 Medical School Biochemistry and Genetics flashcards to review for Step 1 of the USMLE, which is the United States Medical Licensure Exam 1. So if that was a mouthful for you, feel free to ask questions, but for now I'm going to continue going on forward, and we have about 38 minutes left in this study session. So I'm going to relook at this one. So I don't know the answer to this one. So it's signal recognition particles bind to the ER surface signal sequence. Okay. So you have the signal recognition particle binds to the ER signal sequence. Then they go to the SRP receptors and they bring the entire thing with it. So it looks like it's still being translated here because this is the ribosome. It looks like the mRNA is translated. Here's the mRNA, and then this is the protein. And it looks like the N-terminal signal sequence because it's proteins are made in the N to C direction. N meaning nitro and C meaning carboxyl. And this is going to be the part of the signal sequence that the SRP, the signal recognition particle, binds to, brings it all the way to the protein translocator, and then starts its translocation from the cytosol into the ER lumen across the ER membrane. Okay, I went through that pretty fast, but hopefully I can remember that. In most cells, the globin gene is heavily methylated. So this is actually in relation to sickle cell anemia. So only used in RBCs so that not needed to transprise in other cells. Okay, very good. Via blank, segments of DNA are moved from one place to another, different proteins or translocation or rearrangement. You know, same thing. So they can take different things from different gene segments and put them together, create a heavy chain gene. The 3' untranslated region is the region of the mRNA after the stop codon. Termination codon is another word for that. Prokaryotes and eukaryotes. So you have your so I think prokaryotes don't have any caps, tails, or introns, and eukaryotes do. Yes. Blank translate proteins destined for the ER, Golgi, endosomes, lysosomes, or cell surface. I'm going to guess that this is going to be I'm going to guess that this is going to be membrane-bound ribosomes? ER-bound ribosomes. Okay, that's good. I got that right. Blank are responsible for oxidation of toxic molecules. That's going to be peroxisomes. The destinations of blank are determined by signal sequences, proteins, whatever. Okay. Free ribosomes and membrane-bound ribosomes differ in the proteins that they carry. So you have your free ribosome cycle up here. So the ribosomes come up and they're translating this mRNA into proteins. So the protein gets longer in the elongated cytosolic polypeptide chain. Then it comes over here. They disassociate, and that's kind of like the chain in here. And they can make polysomes in here. That's a polysome right there, but they call it a polyribosome. Then you have the membrane-bound ribosome cycle, which is against this ER right here, That's the endoplasmic reticulum, or at least a segment of it. And it takes these free parts in here, they assemble, start translating, sorry. Then you have this N-terminal signal sequence. It's only found on the membrane-bound ribosome cycle. So sometimes it depends on what the mRNA is. If the mRNA has the signal sequence to be translated, then it will do it. Then it's going to come down here to, this is the ER protein translocator. It comes down here. Signal sequence binds to it. Now, if you remember from the previous section, that the not SRY, that's the sex chromosome. The SRP, signal recognition particle, is the thing that binds to this red thing right here, which is the N-terminal signal sequence of ER proteins. And then it brings it down here to the protein translocator. So once this polysome or polyribosome is bound to the endoplasmic reticulum, it's this protein will be translated into here. So got that right. Regulating gene expression. So the post-transcriptional regulation types. If you remember the central dogma obviously is you got DNA, it goes to RNA, and then it goes to protein. So this is after it goes to protein. No, after it goes to, RNA. What can we do to regulate this RNA? So there are plenty of things we can do. So I think I know all these. Let me think. So you can add a 5' cap. So you add a cap to the 5' end of the mRNA. You can add I think it's adenine tail. It's not adenosine. That's more of nucleic acids. Adenine tail, and that both of those kind of protect both ends of the mRNA from degradation. They keep them more stable. It keeps them from being just destroyed by other destroyer proteins. So it promotes stability. It also enhances transcription or translation eventually of the mRNA. So then you have those two things. You have RNA splicing, which is taking out the introns, and obviously, and then you also have RNA stability, mRNA stability. Then you also have mRNA transport. So let's see if I got those. So you have alternative splicing, I said that. Polyadenylation, so that's the adenylates at the end of the 3' tail of the mRNA, or mRNA editing, similar to taking out the, so that is a little bit different. mRNA transport and stability I got. So I got mRNA editing, but I didn't say it in the correct way. So I'm going to give it a 1 day. Blank is responsible for modifying, storing, and packaging proteins and lipids. So this is going to be your Golgi apparatus. I got that wrong earlier. I'm ashamed of that. Signal sequences and proteins are required for translocation into, organelles or out of the cell. Important to organelles, very good. Blank translate proteins destined for cytosol, nucleus, mitochondria, and peroxisomes. So these proteins are translated by free ribosomes. Okay. I'm going to give that 2 days because this one is kind of a tough pill to swallow because I don't understand the pathways. Translation of soluble proteins in the endoplasmic reticulum. So you have the 3', in this you're going to have the I'm thinking. So in this, you're going to have protein translocator binds to the signal sequence. So it's pretty simple, I guess. I was thinking of something more complex or specific. Okay. Blank transcription factors bind to cis-acting elements and communicate with the initiation complex directly or indirectly. This is going to be your general your sequence-specific transcription factors. Because if they can act indirectly, it would be your sequence-specific. Okay. Blank synthesizes most lipids. This is going to be your smooth endoplasmic reticulum. Blank, your rough endoplasmic reticulum is the site of protein synthesis and distribution to many organelles. Good. Blank protrudes from the cytosolic surface or systolic. Systolic doesn't sound right. So cytosolic surface of the nuclear pore and interact with the nuclear protein import receptor complex. This is going to be your cytosolic fibrils. So this is the nuclear basket. You got your cytosolic fibrils, and these kind of interact with the nuclear import receptor, which is actually bound to the nuclear localization signal on the prospective nuclear protein, which is going to end up in the nucleus, right? It's going to be your cargo in this instance. So I got that right. Blank affect the action of the promoter causing changes in transcription. This is going to be, just transcription factors, enhancers, and silencers. Sure, any of the above. I'm going to continue on with this one because I'm not worried about it. Prokaryotes and eukaryotes, the differences. So prokaryotes are all haploid. They have no diploid genome portions. Eukaryotes have haploid and diploid. The haploid are in the germline or the germ cells, and the diploid are in the somatic cells. Genes can be blank so that functional protein is not made, which means it can be deleted or partially deleted. Let's see. Yep. Blank are embedded in some manner in the ER membrane and are destined to reside in the plasma membrane or the membrane of an organelle. Membrane-bound proteins. Yep. Protein import into the mitochondria. So you're going to have an N-terminal signal sequence which binds to the mitochondrial import receptor. Good. Blank binds to a prospective nuclear protein that has a nuclear localization signal. This is going to be... So if it's a nuclear protein, it's going to be your nuclear import receptor, which is NIR. Yep. Blank are responsible for intracellular degradation. Just in general, lysosomes are, but lots of things could be as well, so it's kind of a poor question. A missense mutation may or may not cause a phenotypic change, because this is a change in amino acid, but you don't know if it causes a phenotypic change. Because if it causes a amino acid change, it could be the same could cause the same... What am I trying to say? It doesn't have to cause a phenotypic change. Could be a silent mutation. It's not a silent mutation. Yeah, it's not, because it's amino acid change. Okay, this question seems a little bit derpy. What is the central dogma of molecular biology? This is the most simple question I'm going to get all day. So it's going to be DNA, RNA, protein. Prokaryotes have no nucleus. Eukaryotes do. Now you could argue that prokaryotes have nucleolus, but no nucleus, so it's not membrane bound. It's kind of just out there. The DNA is just there. The 5' end of a new blank chain starts with triple phosphate, so triphosphate adenosine or triphosphate guanosine. So this is going to be when you start transcription and create mRNA. Correct. The open reading frame of some mRNAs are edited after transcription, resulting in changes in the codons. Yeah. So, okay. Not phenylalanine. Is that what it's called? Phenylalanine? tRNA phenylalanine denotes that. So the one that's attached to it by a dash is what it's attached to. The superscript is the anticodon of that tRNA. So the amino acid, yes, okay, got it. Blank was located within the transcription factor 2 domain, which is going to be your TATA binding proteins, your TBPs, TATA binding proteins, TBPs. TATA box is a blank that is highly conserved in many promoters. TATA box is a blank that is highly conserved in many promoters close to the transcriptional start site. It is a cis-acting element, I believe. Yeah. Retroviruses. In the host, virus RNA is reverse transcribed into DNA. When viral DNA is integrated into the DNA of host to form DNA progeny, which is then just transcribed to form viral progeny. The DNA provirus, which is then transcribed to form viral progeny. Yes. All right. Blank binds to ER signal sequences on proteins in the cytosol. This is going to be your signal recognition particle. Then they bind to the ER. This is going to be your ER import receptor. No, ER transloc. Yeah, SRP receptors. Okay, I got that wrong. One gene, multiple products. So you have RNA splicing, RNA editing, and alternative polyadenylation. Somehow, there are multiple. Oh, so there's alternative polyadenylation. Alternative polyadenylation results from there being multiple polyadenylation sequences within the gene. I did not know that. I don't remember this. Again, I learned this back in August. This was a this might have been a 5-week block, but there was so much crammed into it, I can't remember. I mean, this is all going to take a while to come back. So the 3 or 5 prime sequence of all tRNA is CCA. This is going to be your 3 prime sequence. In RNA polymerase 2, your TATA binding protein and your transcription activation factors are examples of general transcription factors which form the initiation complex which binds to the promoter close to the transcriptional start site. Yep. All right. Blank RNA form a ribose. Thank you, I appreciate that. Deep focus. Blank RNA form a ribonucleoprotein complex known as the signal recognition particle. Funny. My name's Zach. Blank RNA. So this is going to be your 7S. No, this is going to be your. This is going to be your. I want to say small nuclear. 7SO. That's a type of small nuclear, but I'm going to say I need to be more specific. I'm going to mark that as wrong. Okay. In eukaryotes, most translational regulation affects the blank of protein synthesis. Let's see. I'm going to say the initiation. Yeah, okay. The translation of globin mRNA is regulated by... Translation of globin mRNA. Hi, aesthetic vibes. The translation of globin mRNA is regulated by heme. Translation of globin mRNA is regulated by heme iron-containing concentration. That makes sense, because this has to do with sickle cell anemia. Alright, let's go back. As RBCs mature, their DNA becomes less condensed. More. Oh, I got that wrong. I'm stupid. When RBCs mature, you guys are being funny. That's funny. Alright, I gotta focus. When RBCs mature, they extrude their nuclei. The RBC lifespan is about 120 days. And RBCs are red blood cells. Person without HIV has about blank lymphocytes per microliter of blood. Oh, I don't know. 100,000, that's what it was. Yeah, 100. I don't even know this. AIDS patients typically die of opportunistic infections. The translation of globin mRNA What does giving eye surgeon, not neurosurgeon mean? He's the only neurosurgeon here. I don't think I'll be a surgeon. I might go into primary care. Alright, the translation of globin mRNA is regulated by, I believe it's heme iron-containing concentration. If we have low iron, we do not synthesize globin for our red blood cells. As RBCs mature, their DNA becomes more condensed. HIV has a high mutation rate due to reverse transcription. Yeah, so it's low fidelity reverse transcriptase. Reverse transcriptase. Translation of soluble proteins in the ER. Blank. So, I think the signal recognition particle binds to this ER N-terminal signal sequence. Protein translocator binds to the signal sequence. I am married, I'll say that. Sorry, deep focus. Protein translocator binds to the signal sequence. Combination therapy is most effective in treating HIV due to the diseases. No, you're good. You're good. Combination therapy is most effective in treating HIV due to the diseases. I'm going to guess highly evolution rate. Yeah, rapidly evolving reverse transcriptase. Good. AZT, that's a drug that targets reverse transcriptase. Thank you, Aesthetic Vibes. Yes, she is. One theoretical way to get around the high mutation rate of HIV in developing treatments. is looking at, I don't know, treating the hosts. Okay. Don't worry, deep focus. I can tell a joke. You're good. Blank is an antibiotic that binds to prokaryotic RNA polymerase, interfering with the formation of the first phosphodiester bond, inhibiting RNA synthesis. You see, this has been so long. It's been since August. I don't remember this. Rifamycin. I can't remember this. Wow. I'm gonna have to look this up. Rifamycin. Let me turn this off for a second. Rifamycin is used to treat traveler's diarrhea that is caused by a bacteria called E. coli. Okay, so rifamycins are antibiotics synthesized by bacterium amylocalipatosis. I've never heard of that, and I was a micro major as well. Huh. Okay. Interesting. Rifamycin is an antibiotic that binds to prokaryotic RNA polymerase, interfering with the formation of the first phosphodiester bond, inhibiting RNA synthesis. Whoops. How do I go back? Undo. Let me do Control Z. Okay. One theoretical way to get around the high mutation rate of HIV in developing treatments is looking at okay, I've got a new goal for today. I think it's to get through 100 of these. So I'm going to get down to 2,155, hopefully. It might take me 2 hours, and then I'll do the last 2 hours writing. I might not have time to read any Eusebius today, unfortunately, but it's all okay. Or depending on what happens today, I can extend the stream if necessary. Well, I'm not really sure what went on in the comments here just a minute ago. I'm tempted to think it's one of my friends, but this seems like a lot of work just for a small joke. Alright. One theoretical way to get around the high mutation rate of HIV in developing treatments is looking at treating the host. A person without HIV has about 1,000 T lymphocytes per microliter of blood. Blink is an antibiotic that binds to prokaryotic RNA polymerases as rifamycin, interfering with the formation of the first phosphodiester bond, inhibiting RNA synthesis. One gene, multiple products. You got RNA editing, alternative polyadenylation, and RNA splicing. Blink is a toxin for poisonous mushrooms that binds to RNA polymerase 2 and therefore blocks eukaryotic RNA synthesis. This is one, oh man, what is this one? It comes from poisonous mushrooms. What is this one? Alpha amantin. Okay. Does not block prokaryotic RNA synthesis since it does not use RNA polymerase 2. Oh, okay. I see. It does, though. Oh. So, alpha amantin comes from poisonous mushrooms and it binds to RNA polymerase 2, so it blocks specifically eukaryotic RNA synthesis. Alright, let me do that hard. In eukaryotes, the most translational regulation affects the initiation of protein synthesis, so usually those polymerases. Blank RNA form a ribonucleoprotein complex known as a signal recognition particle, which delivers newly synthesized protein to the ER. We went over this. This is going to be your 7-SL RNA. Prokaryotic protein synthesis inhibitors. Oh my gosh. Okay. I don't even know. Tetracycline, chloramphenicol, erythromycin, streptomycin, neomycin, kanamycin, gentamicin. So let's see. Strength. Alright, let's make a little thing for this. Let's see. This could be, so let's see, prokaryotic protein synthesis, just translation, inhibitors. And this is going to be, Stang. We could do TC. Okay, let's see. I don't know what to do for this one. I think I might just have to memorize them. Alright, let's see. Prokaryotic protein synthesis inhibitors, tetracycline, chloramphenicol, erythromycin, streptomycin, neomycin, kanamycin, gentamicin. Alright, let's see. The RBC lifespan is about 120 days. AIDS patients typically die of opportunistic infections. Blank is a toxin for poisonous mushrooms that binds to RNA polymerase 2 and therefore blocks eukaryotic RNA synthesis. This is going to be your alpha amantin. That's our second drug. We have rifamycin and alpha amantin. When RBCs mature, they extrude their nuclei. Blank bind to the ER signal sequence on proteins in the cytosol. This is going to be This is going to be blank binds the signal sequence on proteins in the cytosol. Your signal recognition particle binds to ER signal sequence on proteins in the cytosol. Then they bind to the signal recognition particle receptor on the rough or endoplasmic reticular surface, and which feed the protein through a protein translocator in the ER lumen. Alright, got it. As RBCs mature, the DNA becomes more condensed, I guess, somehow. But actually, let me go back on that one. More bound to histones and not transcribed. Okay, that makes sense. Translation of soluble proteins in the ER. So the protein signal sequence binds to the protein translocator on the ER surface. Yeah. The translation of a globin mRNA is regulated by the heme concentration, so the iron concentration. If we have low iron, we do not synthesize globin for RBCs. AZTs targets the HIV reverse transcriptase. HIV has a high mutation rate due to low fidelity reverse transcriptase. Eukaryotic protein synthesis inhibitors. So we have our alpha-mantin blocks eukaryotic transcription. Then we have rifamycin blocking prokaryotic transcription. Now we have eukaryotic translation. It's going to be your cyclohexamide diphtherotoxin and ricin. Now, if you remember from Breaking Bad, ricin was a big, that was a big plot point in Breaking Bad. This ricin, so it blocks eukaryotic protein synthesis inhibitors. It's found in some plants. I don't know what the plant is called. It might be called a ricin plant. I don't know. So I got this one wrong, definitely. Combination therapy is most effective in treating HIV due to the disease's rapidly evolving reverse transcriptase. Good. Prokaryotic and eukaryotic protein synthesis inhibitors. There's one that crosses over between both prokaryotic and eukaryotic translation. I don't know which one this is. Pyrimycin. Okay. I did not know that. Blank is an autoimmune disease caused by antibodies against a number of nuclear and cytoplasmic antigens, resulting in chronic inflammation. Is this SLE? Yes, it is. Okay. So you have small nuclear RNPs, ribonuclear proteins, which are the targets of these antibodies. So symptoms of systemic lupus erythematosus may vary widely, depending on the individual. So look at these. You have these butterfly rashes on the cheeks. That's very notable for patients with SLE. Most patients have joint pain and swelling, which we'll get into in the musculoskeletal block. So I'm assuming at the end of summer we'll get into that kind of stuff. Maybe midsummer. Bad movie, by the way, Midsummer. I didn't like it. Butterfly rash on the cheeks is seen in about half the patients, so it's pretty common. And it's both young and old. You can see it on both. So, okay. So I'm going to say I got this one right, but not completely. Eukaryotic protein synthesis inhibitors. This is going to be your cyclohexamide, your diphtherotoxin, and your ricin. Wow, only took one review. That's great. Prokaryotic and eukaryotic protein synthesis inhibitors. This is going to be your pyrimycin. Most systemic lupus erythematosus patients exhibit blank, and roughly half of patients a butterfly rash on the cheeks. So I'm going to say joint and pain and swelling. Butterfly rash is seen on the cheeks. Very good. Small ribonuclear proteins combined with pre-mRNA and other proteins to form a spliceosome. This is involved in the translation or post-transcriptional splicing of mRNA. My bad. Okay. So small ribonuclear proteins combine with pre-mRNA and other proteins to form a spliceosome. I got that wrong for sure. To be honest, I don't really know what SNRPs are. I know what they're made of. I can tell by the name of the roots of the word, but I can't tell what it does. But it combines with pre-mRNA, so that's unedited, and unedited mRNA and other proteins to form a spliceosome. Oh, this is just used to make the ribosome. Except this is just used to make the spliceosome, so it could do alternative splicing before it's translated. That makes sense. Blank results from males who produce androgens but lack the intracellular androgen receptors, preventing masculinization. This is not Swyer syndrome. This is feminine testicularization. Testicular femininization. Yeah, bilateral enlargement of the mammary gland. So this is actually a guy. Yeah. Blank is a cancer of white blood cells that results from DNA rearrangement translocation between chromosomes 9 and 12. Okay. Oh, man. I can't remember, but it's going to be obvious. Yep, CML. Sometimes it takes reviewing things to cement them in your mind. I'm going to pour some of this coffee because I can tell I need it. Let's see. All right, back to it. So we have chronic myelogenous leukemia. Leukemia is spelled wrong on that. Which, actually, let me fix this real quick. I can see it's a little bit off on there. There we go. And this is going to be a cancer of white blood cells that results from DNA rearrangement between chromosomes 9 and 22. So there's clear genetic abnormality that kind of causes this. Can be visualized with fish, which is fluorescent in situ hybridization, which I've done many times in the lab. It's a fun little experiment. Prokaryotic protein synthesis inhibitors. Listen, oh man, this one's going to kill me. Okay. Cyclophosphamide, tetramycin, I don't know, gentamicin, kanamycin, I don't know. Okay, chloramphenicol, tetracycline, erythromycin, streptomycin, neomycin, kanamycin, gentamicin. Wow, I butchered that one very badly, so I'm going to give that one a bad. Person without HIV has about blank T lymphocytes per microliter of blood, about 1,000. Blank is an antibiotic that binds to prokaryotic RNA polymerase, interfering with the formation of the first phosphodiester bond, inhibiting RNA synthesis. So RNA synthesis is inhibited by erythromycin. Wait, it binds to prokaryotic RNA polymerase. Okay. One theoretical way to get around the high mutation rate of HIV in developing treatments is looking at treating the host, not the virus. Yep. Blank is a cancer of white blood cells that results from DNA rearrangement and translocation between chromosomes 9 and 22. This is going to be your chronic myelogenous leukemia, CML. One method for cancer resistance to methotrexate is... I don't know this one. Gene amplification. Methotrexate inhibits the dihydrofolate receptor, reducing thymine production for DNA synthesis, decreasing cell proliferation. Some cancer cells treated with methotrexate will amplify their DHFR gene, becoming resistant. Okay. We are almost at the end. Let's try to get a couple more cards in, so I got this one wrong. Methotrexate is an inhibitor of dihydrofolate reductase. Competitive inhibitor versus dihydrofolate. That makes sense. Okay. Blank is caused by missense mutation in the beta globin chain of the hemoglobin and presents phenotypes under low oxygen conditions. This is going to be sickle cell anemia. Individuals heterozygous for sickle cell anemia have resistance to malaria. Alright, let's sync this up. We got quite a bit done actually. So I will hide this sharing screen now. Now I'm going to We have about a 10-minute break time, and then we will start back on that. In this 10-minute break time, I'm actually going to watch a video by The Last Resort Network, the YouTube channel that we're on, that was just posted about an hour ago, by my co-host, Ben Stanhope. And if you haven't checked us out yet, please check us out. We also have a podcast that we've been doing for about 5 years about movies. It's called The Movie Vault. Just high-quality content on there. Go check it out. And I've got my coffee crackers up here. I don't know what language is on these, to be honest. My wife bought these. So.
Welcome back to Last Resort Network. This is Ben. If you enjoyed our video on the 6 movies you should watch from the 1960s, well, you're in luck. Time didn't end in 1969. In fact, in many ways, in cinema, life had just begun. The 1970s was a huge opportunity for filmmakers to experiment and progress the art form further. With the Hays Code being destroyed, there was many opportunities to make things that hadn't been made before. This era is often defined with grimy and experimental films. If you want to know which films are important to watch from this time period, well, you're in the right place. Today's video is 7 movies you should watch from the 1970s. American Graffiti is a coming-of-age tale centered around high school students on their last night before leaving for college. Richard Dreyfuss and Ron Howard star in this pre-Star Wars George Lucas film. 2 elements of this movie make it particularly interesting. One is that the movie is set in one night. It is very immersive due to this. You really get to know these kids even though you only see one cross-section of their life. Secondly, it really leans into nostalgia. Being set in the early 1960s, there is still a lingering of 50s nostalgia in the film. This is something you see a lot nowadays, but was very new back in the 1970s. We are also introduced to a young Harrison Ford, and the soundtrack, led by Wolfman Jack, is killer. If you like the movie Dazed and Confused, you'll definitely like American Graffiti. Hardly an unknown director now, there was a time when Martin Scorsese was a young, hungry filmmaker. It was in this movie, Mean Streets, that he found his star, Robert De Niro. But you also have to appreciate the real lead of the movie, Harvey Keitel, who had just enough star power at the time to headline this film. The religious struggle of Charlie, Harvey Keitel's character, is possibly the best aspect of the film. De Niro's wild performance as Johnny Boy Savilo is also incredible. Mean Streets may not be the best combo of De Niro and Scorsese, but it is an important one as it showcases the beginning of their relationship. Scorsese shows flashes of brilliance, but also a rawness that is very refreshing. Personally, my favorite aspect of the film is Keitel and his struggle to reconcile his life of crime and his fate. Scorsese has always impressed me with his ability to write flawed characters who still have a chance at redemption. Over in Italy in the 1970s, Giallo was in full force. Mario Bravo had made many memorable movies in the 60s and would continue into the 70s.
Hey, Wesley and Ben. I'm watching your 1970s video right now on my break.
From Italy is Dario Argento. Deep Red is a sharp, thrilling movie about a killer. In combination with Goblin, his synth-driven soundtracks are also an incredible aspect of his films, and that began in Deep Red. If you want an introduction to Argento and Giallo in general, this is a great place to start. British actor David Hemmings stars as a musician who starts investigating a series of murders performed by a mysterious person who wears black leather gloves. Argento is a master of blending thriller and horror genres. Deep Red starts out as a standard killer thriller, but then adds supernatural horror elements and a shock twist to make it stand out as one of the best the genre has to offer. Watch Deep Red if you want a great introduction into Giallo. In my opinion, in Dog Day Afternoon, we witness Al Pacino's greatest performance. Pacino stars as Sonny Wardsick, a small-time criminal who has aspirations of pulling off a bank heist. The robbery immediately goes south, and Wardsick and his partner Sal find themselves holding the bank and clients hostage. From this point, Sonny tries to portray himself as a revolutionary figure, and his complex motives for pulling off the heist are revealed. Pacino's ability to breathe life into Sonny Warsick's character is a revelation. For an actor of Pacino's reputation, it is sometimes hard to pull off a performance where the audience forgets who you are and completely buys into the character you play. Dog Day Afternoon is just that performance. Definitely watch this movie if you appreciate great acting performances. John Cassavetes is a staple of 1970s cinema. I considered placing one of his directorial works on this list, but instead I opted for Elaine May's Mikey and Nicky. Peter Falk stars as Mikey opposite Cassavetes' Nicky. They are both low-level mob criminals, but Nicky has fallen out of favor with the boss, to the point where a hitman is following him. In the beginning of the night, Mikey sets out to help Nicky, but as the evening unfolds, tension within the friendship takes the forefront. May utilized an improvisational style, leaving film running in order to catch Cassavetes and Falk in the moment. She also used 3 cameras to catch multiple angles. Paramount claimed Final Cut as the film went way over budget, and you have to imagine it was not fun editing this movie. The Hangout Gone Awry storyline works really well for me, and I think this film captures what was really special about making movies in this era. A movie like this would never be made today, let alone produced by a big budget studio. May's career was definitely hurt by this, but I'm glad she was able to accomplish it, as it certainly is an underrated piece of 1970s cinema. Days of Heaven is truly one of the most beautiful shot movies ever created. Terrence Malick came into his own in this sweeping, portrait-like American epic that recreates the biblical tale of Abraham and Sarah and their deception while in foreign lands. Malick takes us on a journey to the Texas Panhandle. The farmer, played by Sam Shepard, provides opportunity to those journeying west looking for a better life. Brooke Adams, Abby, and Linda Mann's Linda travel through to the farm. They have an opportunity to create a better life for themselves. However, when Bill overhears that the farmer only has 1 year to live, a chance at a con is created. Malick's style in his later career is perhaps more what he is known for, but Days of Heaven should not be forgotten. I'm not kidding when I say this might be the most beautifully shot movie ever. We have a full review on Days of Heaven on episode 128 of the Movie Vault. The final film on this list is the most obscure. Killer of Sheep has a fascinating history. Filmmaker Charles Burnett made this as a thesis film for UCLA Film School. The film won awards at film festivals, and yet never saw a wide release because the 22-song soundtrack couldn't clear copyright issues. In 2007, it was finally released on DVD, and has also finally started gaining the recognition it deserves. The film follows Stan, who lives in the Watts neighborhood of LA, and works at a slaughterhouse. It has a loose narrative, but focuses on how Stan feels stuck in the life he is in and is powerless to change his circumstances. The roof jumping scene is particularly famous, and many critics have written on why they feel it is impactful. Burnett would go on to have a great career in his own right, but very few students can claim that they made a thesis as amazing as his. So those are my recommendations from the 1970s. There are some truly amazing movies in this era that I didn't even mention. After all, the start of the blockbuster came in 1970s. So perhaps the death of cinema was started in this era as well. Oh, and there's a little movie called Star Wars that came out at this time. But I know all of you already know about those films, so hopefully this pushes your film watching in a new direction. If you like or hate any of these movies, please comment below. If you like this content, like and subscribe. The series is going to continue, so you don't want to miss out. Alright, this has been Ben from Last Resort Network, your last resort for movies and more.
Very good. Love it. Love it. Okay. That is very good. I'm going to go get a package from the porch that I ordered, and then I will come back, and then we will start back up. We got about 2 minutes. I'll be right back. Alright, I'm gonna get back to studying. I'm gonna do some of my flashcards. Alright. Let's get the timer back up. So I'm gonna restart that. And we're good. Alright, session number 2. So for those of you just joining, I'm going to do a little bit of flashcards. I use this ANKI remote. And I'm going to share my screen of this. So my goal, we have 2,230 flashcards left. My goal is to get to 2,155 tonight, or today. At least in the next 2 study sessions. And then I will begin writing my paper right after that. I have a seminary paper to write. I would like to actually play some piano as well. Let me see if I can do that. I don't know how to do that. Alright. Let's see. Alright, blank results from any mutation that causes a globin protein alpha or beta to be dysfunctional or causes decreased expression of globin gene that causes anemia. I'm going to say sickle cell anemia. Thalassemia, no, got it wrong. Let's see. Most common gene disorder in the world. Decreased wild type protein or globin production or production of the mutant globin can cause decreased functional hemoglobin and thalassemia. So, that's right, because sickle cell anemia is strictly beta. Okay, give me 1 second. I gotta pause the stream just for a second.